Hello everyone, in this course we will learn about welding deformation. The main contents include 1. The harm of welding deformation. 2. Measures to control welding deformation. 3. The method of correcting welding deformation. The first part, the harm of welding deformation. Welding deformation will bring the following hazards. 1. The welding residual deformation of parts or components will bring difficulties to the assembly, and then affect the quality of subsequent welding. 2. Excessive residual deformation needs to be corrected, increasing the manufacturing cost of the structure. 3. Welding deformation also reduces the performance and load-carrying capacity of the welded joint. The second part, measures to control welding deformation. In order to reduce welding stress and deformation, it can be solved from two aspects of design and process. Design measures. 1. Select a reasonable weld size and groove form. Generally, under the condition of ensuring the bearing capacity of the structure, the smaller weld size should be used as much as possible in the design. For T-joints and cruciform joints with greater stress, under the condition of ensuring the same strength, the open grooved weld has less weld metal than the general fillet weld, as shown in the figure, which is beneficial to the comparison less welding deformation. 2. Reasonably determine the length and quantity of the weld. The length of the weld has an influence on the welding deformation. So on the premise of meeting the strength requirements and sealing requirements, the continuous weld can be replaced by the intermittent weld to reduce the welding deformation. In addition, the number of welds should be minimized during the design process. For example, in the thin shell structure, appropriately increasing the thickness of the wall plate can reduce the number of rib plates and achieve the purpose of controlling welding deformation. 3. Arrange the position of the welding seam reasonably. Make the welding seam as much as possible to form the neutral axis of the fish section, or make the welding seam close to the neutral axis. The deflections cancel each other out. The weld is close to the neutral axis, which reduces deflection caused by the weld. As shown in Figure A, the welds are concentrated on one side of the neutral axis, and the bending deformation is large. The welds in figures B and C are symmetrically distributed and arranged reasonably. In the rib design of Figure A, the welds are concentrated below the neutral axis, which will cause the bending deformation of the upper arch. In the design form of Figure B, the welds are symmetrically distributed on both sides of the neutral axis, which can reduce and prevent the occurrence of bending deformation. The control measures in the process mainly include the residual method, the anti-deformation method, the rigid fixing method, the selection of a reasonable assembly welding sequence, the reasonable selection of the welding method and welding process parameters, the heat balance method and the heat dissipation method. 1. Remaining margin method. This method is to appropriately increase the length or width of the part than the design size when cutting to compensate for the shrinkage of the weldment. Anti-deformation method. First judge the size and direction of the deformation of the structure before welding, and then give a deformation in the opposite direction during assembly or material preparation. In this way, the welding deformation can be offset after welding and the size requirements can be guaranteed. Rigid fixing method. In the absence of reverse deformation, rigidly fix the weldment components to limit the welding deformation. However, for materials such as cast iron and easily hardened steel, cracks are likely to occur when the deformation is blocked. So this method should not be used. Figure A shows the welding of the T-beam under rigid clamping, and Figure B shows the rigid fixation of the butt joints. The fourth method. Choose a reasonable assembly and welding sequence. The assembly and welding sequence has a great influence on the deformation of the welded structure. Therefore, In the case where the tire fixture cannot be used, a reasonable assembly and welding sequence can also be used. Welding distortion is minimized. The welding seam being welded should be as close as possible to the neutral axis of the structural section, as shown in the figure. 1. Assemble the large and small ribs in the upper wing plate first, and weld the A welding seam. At this time, the welding seam A is basically close to the neutral axis of the structural section, with minimal deformation. 2. Assemble the left and right webs at the same time, and weld C and B welds. Since the welds are basically symmetrical to the neutral axis of the structural section, the lower deflection deformation is small. The structure with symmetrical arrangement of welds should be welded symmetrically by even-numbered welders. The figure shows the welding sequence of the butt welds of the cylindrical body. For the welding sequence of long welds, more than 1 meter, it is mainly divided into several methods. A. Subsection de welding method. B. Alternate welding method. C. Jump welding method. D. Subsection welding method, as shown in the figure. For the welding sequence of 2 adjacent welds, the sequence of figure B is correct. 5. Reasonably select the welding method and welding process. For the welding of asymmetric cross-sectional structure, the distance between the welds 1 and 2 from the neutral axis of the structural section is large, and multi-layer welding is used for welding, and a smaller line energy is selected for each layer. The distance from welds 3 and 4 to the neutral axis is small, and single-layer welding is used during welding, and a larger line energy is selected. In this way, the welding deformations produced by the welds 1 and 2 and the welds 3 and 4 are in opposite directions, and the magnitudes are basically equal, and they cancel each other out. And a straight member is obtained after welding. 6. Heat balance method. The gas flame and welding are used for simultaneous heating at the position symmetrical to the weld. As long as the heating process parameters are properly selected, the bending deformation of the component can be reduced or prevented. 7. Heat dissipation method. The third part. The method of correcting welding deformation. When the residual deformation in the welded structure exceeds the deformation range of the technical requirements, the deformation of the weldment must be corrected. It mainly includes manual correction method, mechanical correction method, and flame heating correction method. The manual correction method is to use a handhammer, a sledgehammer and other tools to hammer the deformation of the weldment to make the material extend to compensate for the welding shrinkage. It is mainly used for the bending deformation of some small simple weldments and the wave deformation of thin plates. The mechanical correction method is to extend part of the metal under the action of mechanical force, produce tensile plastic deformation, and restore the deformed component to the required shape. Specifically, it is to use jacks, tensioners, presses, etc. to straighten or flatten the weldment. The mechanical correction method is generally suitable for welding parts with relatively good plasticity and simple shapes. Flame heating correction method. The picture shows the flame correction of the bending deformation of the I-beam. Triangular heating means that the heating area is triangular, which is generally used to correct the bending deformation of structures with large stiffness and thickness. When heated, the base of the triangle should be on the arch of the structure to be rectified, and the top should be in the bending direction of the weldment. Students, this is the end of this lesson. Thank you for watching.